Hello, you guys. Let me just check the mic's on. It is on. Perfect. So we are on lesson 12, units in scale drawings. I'm gonna be honest with you guys. Units, that's like one of my weaknesses in math. I have a lot of trouble with units. So just letting you know, I studied really, really hard to try to understand a good way, an easy, simple way to explain it. So we're gonna be using different scales to describe the same drawing. You might hear my mom and my cat in the background, so just ignore it. Anyways, so ignore that. In the warm-up, we're skipping that. So this is activity 2, the world's largest flag. Change to red. Largest flag, page 95. So this might look like a sandy beach and someone just like threw like a towel on the ground. But in reality, that picture is this. These are people. This is a giant flag. You want to know how hard, how like really big it is? This is a truck. It's gigantic. So if you look at page 90, I believe it's 95 still. Yeah, page 95. As of 2016, Tushunia holds the world record for the largest version of their national flag. This one. It was almost as long as 4 soccer fields. All those soccer fields y'all see on TV, there's 4 of those make this flag. The flag has a circle in the center and a crescent moon inside the circle and a star inside the crescent wing. So you'll kind of see like the moon here. It's hard to see, but it looks like this. Looks like this, and then it has a little star like this right here in the middle. So we need to complete this table. It says here, the actual lengths are all over here for the flag length, flag height, and height of the crescent moon. And then it says here that we're at a scale of 1 to 2,000. And we have, looks like miniature versions here because it says centimeters, and then they are going to be lower. So let's break down what this scale is because we have to use that scale. So if we are, so this is how much bigger or smaller something is getting according to the drawing. So it's 2,000. So if it's getting larger, it is times 2,000. If it is getting smaller, the scale drawing is getting smaller, then it is dividing. Oh wait, no. We are multiplying by 1 over 2,000. Or if you just want to keep it simple, even more simple, divide by 2,000. If it's getting smaller, you divide by 2,000. There you go. So from here to here, so I see that the flag's actual length is 396. Actual length is usually bigger. The real one is bigger. A scale drawing usually might be a little smaller, maybe a little larger, depending on what it says. But usually actual or real one means that they're looking for a real big size. So this is meters, 396 meters. So we have at 1 to 2,000 scale. So it seems like we are going to go smaller. So we will divide by 2,000 to make it smaller. Now, try to leave yourself a little bit of space because you are going to write a little bit here. Because I can already see that we're going to write this in centimeters. Centimeters. So we need to use it. We're going to be using this measurement here, or this 1 meter equals 100 centimeters. So 396 divided, I'm using a calculator, divided by 2,000. If you use that on a calculator, you should get 0.198. I'm leaving a little bit of space, and it's meters. But now look, we need to turn that into centimeters. Realize what it says. For every meter, we'll have 100 centimeters. For every meter, we have 100. So we need to multiply by 100. So times 100, and that'll give us 19.8 centimeters. There you go. Just so you know, even though we multiply by 100, these two are still the same. They're still the same thing, just different measurements. This is it in meters, and this is it in centimeters. All right. Now, looking at this one, pause the video, see if you can do it on your own. This is the small one. We want to go to the actual height. Are we going to multiply or divide by 2000. Pause the video, see if you could also do it for the height and moon. All right, I'm hoping y'all did that. So it's times 2000 here. And for the crescent moon, it looks like we're going to go lower. So we're going to divide by 2000 because we're getting smaller. It's 2000 times smaller. Here's getting 2000 times bigger. So we're going to put, oh, let me lower it down a little bit. So we're going up. This one, we're going down, just so I have a little bit more space. Okay, so let's do the rest. So 13, I'm using a calculator in my hand. 13.2 times 2000. So it's a big number right now. 26,400. But remember, this is meters. Centimeters, sorry. Centimeters. Because this is centimeters, so it stays the same, centimeters. So we need to turn this to meters. So for every 100 centimeters, I should have 1 meter. I have centimeters here. For every 100 centimeters, I should have 1. So how many 100s do I have in there? And I can find that out by dividing by 100. So 26,400 divided by 100 is 264 meters. There you go. Next one, we have 9 for the height of the crescent moon. We already know it's going to be dividing by 2000. So 99, I'm using a calculator again, is going to be 0.0495 meters. And we need to turn it into centimeters. So meters. Okay, for every meter, I have 100 centimeters. So every meter will give me 100. So I need to multiply by 100 to figure that out, times 100. And that will equal, I'm using a calculator again. Just so you know, using a calculator is okay, especially with like big numbers or like decimals like this. You're more than welcome to use a calculator. Like you're not really using it to copy or to cheat. In reality, you're just using a calculator because sometimes you can't really multiply these giant numbers on one sheet of paper. And that's okay. There you go. Perfect. Awesome. Centimeters and meters. So we need to explain our reasoning though. Remember, to get a smaller drawing, we divided by 2000. To get a larger drawing, I multiplied by 1,000. 2000. Then we divided by 2000. Then after that, how did we get these measurements? Well, we used our tool here. We either multiplied by 100, or we either divided. So we either multiplied by 100 or divided by 100 to get, I believe the times 100 was for centimeters, to get centimeters, and then dividing by 100 was to get meters. Yeah, times 100 was centimeters, and then dividing by 100 was meters. Yeah, a giant flag. I don't know why they decided to break that record. That's like a wild record to break. Okay, we're now going to make equivalent scales right now. They're going to look different, but they're still going to be equivalent. Complete each scale with the value that makes it equivalent to the scale 1 to 2,000. We're going to explain and show our reasoning. Okay, so for number 1, I see 1 to 2,000. I see. Now, I want to remind you, notice that they have no units. If they have no units, basically, they both have the same one. So if they're both inches, that's fine. They're both inches. If they are both meters, then they're both meters. Just know that they are the same measurement no matter what. Okay. I notice here, so I'm going to write my scale 1 to 2,000. And I want to remind you, if it's getting larger, 1 to 2,000. If it's getting larger, we multiply by 2,000. It's 2,000 times bigger. If it's getting smaller, we divide by 2,000. It's getting smaller. Okay, so notice, here's my small one, here's my large one. Well, we already know that 1 centimeter, 1 is equal to 2,000. And luckily, they both have centimeters. So you would just put the 2,000 there because they both have already centimeters. These are 1 centimeter to 2,000 centimeters is the same thing as 1 to 2,000. This is the exact same thing. Let's go to the second one. Oh, did I not erase it? Oops. Ignore the answer. You didn't see nothing. So we have 1 centimeter to meters. So they're not the same. So we need to do that. We're going to change this to centimeters. So we already know we are going to go up. So it's going to be times 2,000. So 1 times 2,000, well, it's just going to be 2,000. So I'll leave it as 2,000 centimeters. So 1 times 2,000, 2,000 centimeters. Awesome. But we need to turn this into meters. So I'm looking at my thing here. So that's going to be, to get to meters, that is going to be, for every 100 centimeters, we have 1 meter. So how many hundreds are in 2,000? So we need to divide by 100. There you go. Divide by 100. And that would be 200 meters. Oops. That would be 200 meters. If you want to use a calculator, 2,000 divided by 100, I'll just go down like this. Wait, is it 20? Hold up, let's see. 2,000, you might hear my phone right now. 20, sorry, 20. 20. 2,000 divided by 100 is 20. 20 meters. Awesome. Let's go to C. Okay. Now, I already prepped this because I already see centimeters and kilometers. We need to change that. So we need to go from centimeters to meters, and then from meters to kilometers. So we need to use 2 of these. So same thing as before. This is the small one. You need to go up. So we're going to multiply by 2,000 because that's our scale, times 2,000 to make them equivalent. So we have 2,000 centimeters. 1 times 2,000 is 2,000 centimeters. Awesome. But now we need to turn this into meters, and then from meters to kilometers. So from centimeters to meters, for every 100 centimeters, we'll have 1 meter. So how many centimeters do we have? So we should be dividing by 100. You probably hear my mom practicing her English behind me. And then once we have meters, we have 1,000 meters. How many thousands do we have to make 1 kilometer? Well, we're dividing by 1,000 also. Dividing by 1,000. And you can go ahead and use a calculator too for that one. So 2,000 divided by 100 is 20. Then divided by 1,000, and that equals 0.02 kilometers. I want you to realize this is still equivalent to this scale, 1 to 2,000. It's the same thing. It's just that we changed the units, which is okay. There's nothing wrong with that. Different units, but they still represent the same thing. Let me make sure. I have my paper. There it is. Okay. Now, letter D. Letter D is next. So now, notice that we are going to get larger still. We're still getting larger. Our scale was 1 to 2,000 up here. So times 2,000. And realize, oh my gosh, we're so lucky. They're both meters. So we can just say, oh, 2 times 2 is 2, and then add the 3 zeros. 4,000. You could have also done this too. 1 to 2,000. Since they're both meters, you could just double it. 2 and then 4,000. There it is. 2 to 4,000. And then just put meters. Yeah. Nice. Okay. Here too. Notice we're going from small to big. So we need to go from here to here. So remember the scale is 2,000. We're getting large. So times 2,000. So times 2,000. Times 2,000 is, oh, but we also have this too. Oops. We also have, these don't match. But we will change it right now. 1 meter equals 100 centimeters. So we have 5 times 2,000. 5 times 2,000 is 10,000. If you put it into a calculator, yes. Centimeters. 5 centimeters to 10,000 centimeters. But we need to turn it to meters. So that means that we need to turn this to meters. So for every 1 meter, for every 100 centimeters, for every 100 centimeters, we have 1 meter. To figure that out, we need to divide by 100. So if I were to divide right now, 10,000, see, divided by 100, I'm using my calculator, it would just be 100. There you go. Realize, I'm using the scale. It needs to be 2,000 times bigger. Times 2,000. That's how I got 10,000. And then I turned my centimeters into meters by dividing by 100, and that gave me 100 meters. Look at this now. This is the large one, this is the small one, so now we're going backwards. Remember, if we're getting smaller, we're dividing by 2,000. Oh, let me put it at the bottom, actually. I am dividing by 2,000. So we're going to do 1,000 divided by 2,000. So now we have 0.5 meters. But remember, I see right here, careful, it needs to be centimeters. So we need to, where is it? Oh, I already have it here. 1 meter equals 100 centimeters. We need to turn this into centimeters. So I see here, we have meters here, so meters. For every meter I have, there'll be 100 centimeters. So that means that I'm going to multiply by 100. For every meter, I should have 100 of them. So 0.5 times 100, and you have 50. 50 centimeters to 1,000 meters. Yes. Beautiful. We love it. We love it. Now for the last one. Again, always pause the video and see if you could do it again. Rewind the video, try to see if you could do one on your own again. Pause this time and see if you can do letter G by yourself. First question you gotta ask yourself, is it getting smaller or is it getting larger? All right, I hope you pause it right there. So right here, it's going backward, it's getting smaller. It's going back. So dividing by 2,000. So we're gonna divide 20 by 2,000, our scale. And we have 0.01, stays meters though, meters. So now, again, we gotta turn it to millimeters. So let's turn it to millimeters. Millimeters. So according to this, we have meters. For every meter I have, there's gonna be 1,000 millimeters. So for every meter, there'll be 1,000. So that's times 1,000. So 0.01 times 1,000. So 10. And I am putting this in a calculator. I'm not doing it in my head. There's no way I'll do this in my head. There you go. Awesome. Remember, rewind, play, do what you need to do to try to see if you could do it on your own. Just remember, every single one of these scales is exactly the same. It just looks different. It has different measurements because we used the same scale of 2,000. When it was getting larger going forward, we multiplied by 2,000. 1 times 2,000. When it was going backwards, we were dividing by 2,000 from this one. It was 1,000 divided by 2,000 because we were going backwards. And then we turn it into centimeters. So as long as we're using the same scale, same thing. Doesn't matter. Okay. Let me go to question. Practice problem. I'll do 2. Number 2. Why am I acting like I just decided that? I already know I was going to do number 2. Aletta finds the area of a house on a scale drawing. It is 25 square feet. Here's something very interesting. 25 square inches squared. That is the area of the house. of the scale drawing. The actual area of the house is 2025 feet squared. Okay, I want to find the scale factor. 25 times what is going to equal this? Well, I can just divide them. So 25 divided by 25. I'm doing this with a calculator, by the way. So this is times 81. So I want you to realize 81 is not the scale factor. Not scale factor. But what it is the scale factor squared. It's the scale factor times itself. So 81 is 9 times 9. So that means that the scale factor, like if we didn't take the area and we just had the two houses like this, like big house and small house before the area, the scale factor was times 9 to get from the small house to the big house. If you find the area, you could find out, hey, this number times, it's 9 times 9 is 81. That means that the scale factor, the original scale factor was just 9. So that's your scale. So what is the scale of the drawing? Well, you have inches and you have feet. For every 1 inch to 9 feet, because that's the scale. There you go. It's very interesting. The scale factor is literally not doubled, but it multiplies itself for the area. So you know that, hey, the area is just the scale factor times itself more. So it's times 81 more if you have a scale drawings. It's the scale factor times itself, and that's how much larger it is. Really cool. Well, y'all, remember, I'm here if you guys need help always. Like and subscribe. The road to 3 subscribers is coming. I can't wait. I'm going to be so rich. I can't wait. Have a good one. Remember, pause, rewind, do all that to make sure that you understand and ask for help in class. Hasta luego. Bye-bye.